This episode of IoT Innovation is sponsored by Anritsu.
Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
This is Jeff Mucci with RCR Wireless News, and this week on IoT Innovation, we're going to be talking about some of the top stories and trends in the industry, as well as an interview with Rupert Baines, who is CEO of UltraSOC. Rupert, thanks for joining us today.
Good to be here, Jeff.
Well, we got a couple stories that have been on our radar screen. I'd love to get your feedback on it. First of all, this race for IoT on licensed versus unlicensed spectrum. Yesterday, I think the Wall Street Journal came out with another nationwide network called Silverlight that's going to be competing with LoRa and Sigfox. I would just like to get your input on what does all this mean, licensed versus unlicensed? How do people really address how they're going to go to market with IoT?
I think it's fascinating that there's one of those rare times where we've got lots of new innovative technologies and we've got some very different business models. On the license side, we've got LTE with Class 0. We've got the next generation of LTE, the proposals coming out of Huawei, out of Vodafone for the narrowband LTE. And yet, on the unlicensed side, we've got the low-frequency Wi-Fi, we've got Sigfox, we've got a whole range of new technologies. And they offer different strengths and different weaknesses, but I think it's astonishing the degree of innovation and the degree of really clever engineering. I haven't got a clue which way it's going to play out, but you have to think this is an incredibly exciting, incredibly dynamic segment because there are so many different approaches.
Well, I think it's been a wake-up call for the carriers who I think assumed that they would fill the void and that the cost of chips would come down and they would be a dominant player here. And I think this has been a real wake-up call for the carriers to accelerate rolling out licensed LTE or GSM type IoT networks, but also driving the cost down of the chipsets required to make it work, because we're really talking about low power, long range, extended battery life type applications. Who do you think is most impacted by the surge of these new technologies?
I think you're right. I think the carriers have sort of perhaps been put on the back foot a little. That historically they've been the only way of doing a national ubiquitous network, and therefore they assumed it was going to be them. And now, as you say, these long-range, unlicensed technologies that offer some very attractive capabilities and are coming to market really quite, people like Sigfox, Jasper, Silverlight are doing some very, so I think at the moment they're the ones who are setting the pace, and the licensed spectrum people need to innovate to compete. Vodafone was actually saying just this a couple of weeks ago, that conventional LTE will be too expensive and that there needs to be a new variety. And they were quite critical of 3GPP for the slow pace. Mm-hmm. That's a legitimate criticism.
Well, I know Vodafone announced with Huawei a narrowband LTE trial. What's interesting is Huawei does make their own chips, so they can make an unlicensed or licensed chip. And I think they've got the scale by virtue of the size of the China market to export that capability to other markets. But you've been in the chip silicon business for a long time. What's it really going to take for the licensed guys to drive down the cost of a LTE-based IoT chip to where it's going to make commercial sense?
I think that's the paradox. I think the current Class 1, Class 0 LTE-based thing have just got too much. They were designed for a different purpose, and retrofitting them to make them into a cheap solution is not going to work. So for a connected car, for a high-value solution, that's great. That's a good way of doing things. But to get it into a low-cost solution, you do need something new and something different. And I think that's the Huawei approach. was designed to do that.
Got
But
it.
otherwise, I think it's a very difficult proposition.
Well, over the last 6 weeks, Orange has made a big push on their IoT strategy. They've launched dual trials. So on the one hand, they announced a LoRa trial, and on the other hand, they announced with Ericsson and Sequans an LT GSM trial. And
Yes.
on that Orange Ericsson Sequans trial, they talked about low cost devices, being able to, with using Sequans to drop the device cost by 60%. They talked about extended battery life, and one of the ways they're able to drive extended battery life is having a single duplex chip versus a full duplex chip. And then they talked about driving in-building coverage by increasing the reach by up to 20 dBs. But clearly, Orange is hedging their bets. Who else in Europe is kind of pushing the envelope?
I think most of the carriers. I mean, it's interesting. You mentioned Sequans, who of course are French. Altair out of Israel is another company doing the same thing. So I think there is the Huawei group is actually based out of Cambridge in the UK. So this is an area where there's a lot of innovation coming out of Europe, which is good to see. But I think one thing we should stress is IoT is not a single market, and it's naive to think that there will be one size fits all. There are a whole portfolio of different use cases, a whole range of different needs, and the kind of connectivity you would want for a connected car or for a high value industrial appliance with lots of data is completely different to the architecture, the business model you might have to say that a street light should turn on or off once a day. You know, there'll be a whole gamut of different technologies at different price points to serve those different needs. And I think that's great because that creates a load of opportunities for operators, systems integrators, chip companies to supply into those different range, but it also makes it very complicated for people like you and I to talk about the market, because there isn't one market, there's hundreds of different slices.
Well, we've seen General Electric, we've heard about Bosch and Schneider Electric and others that are making big pushes to transform their companies into digital companies, which really means IoT. And at the same time, you've seen a surge of these development kits from Intel has a kit, Freescale has a kit, Qualcomm has a chip, a kit, Imagination has a kit, Orange launched their IoT kit. So there are all these development kits out there. Where does an industrial conglomerate start?
Well, I think that's the brilliant thing, isn't it? That if you're a GE or a Honeywell or an IBM or an Accenture or whatever, there is so much of an opportunity to connect things, to add value, to deliver new services and serve the end market so much better. There is a huge value there, a huge business there. And they don't need to develop everything themselves. This is not going to be a vertically integrated make everything. It's, you know, I was at a conference last week, and we should talk about that in a minute. But one of the presentations was IBM talking about the business intelligence and the analytics capability that they're delivering. And they were demoing all of that to a whole crowd of different vertical markets, different industrial partners, but that was all based on Raspberry Pi and other conventional third-party platforms. And that was their point, that they were saying, you can do this with any development system, you can do this with any platform, choose the platform that best suits your need, and then we'll integrate it and accommodate it. And as new platforms come out, that's fine. We'll integrate and we'll accommodate them. And the demo one of them was showing was over the course of a conference call, someone phoned up and said, oh, we're now using a new hardware platform. And how long will it take you to upgrade your architecture to support this new hardware platform? And he was expecting the answer of weeks or months. And the IBM guy was saying, we've done it while we were talking. Because so many of these things are, they all use TCP, they all use standard sockets, they're all running Python, they're all very standards-based, open architecture, horizontal layers, and that makes it incredibly efficient for an end user. In that case, it was a Steelworks. Mm-hmm. But the Steelworks could talk to IBM, who had got a relationship with some service provider. He didn't mention who it was, but whoever it was who was doing the connectivity, whether it be Sigfox or Orange or whoever. And these things can happen, and they're happening at internet speed. They're not happening at traditional system integrator pace.
Or telco pace.
Or telco pace. Going back to what we were saying before is the challenge that people like Orange and Verizon need to wake up to.
I thought it was interesting. We interviewed a product manager from Imagination last week who they rolled out their developer toolkit.
Yep.
They rolled it out by using crowdsourcing on Kickstarter. Yep. And I asked them why, and they said, well, we're trying to reach the do-it-yourself makers. We're trying to reach academia, but we're also trying to reach the enterprise folks to empower them to develop something quickly. So again, it's taking the control out of the existing hierarchy and putting it in the hands of the users. And I think we'll probably see some unintended consequences come out of that, one of which I'd love for you mentioned that event you were at recently, the IoT Security Forum. Tell us about the event and some of the key things that jumped out at you.
It was one of the most interesting conferences I've been to in quite a long time. It was very thought-provoking. There were a lot of presentations from academia, systems integrators, technology, addressing this whole wide range of applications. The key thing, and I can talk a little bit about some of the specific presentations, but the key message was, yes, we all agree this is important. We can all agree this is going to happen, but security is a lot more important and a lot scarier than most people are appreciating. And there are a lot of people who are riding for a fall, and there's going to be some very expensive, very painful mistakes unless we start getting security right.
Who were some of the keynotes and the specific speakers that kind of made you start thinking about the security aspects of IoT?
So the guy who did it, there was one good news story and one less good news story. The good news was the hacker who had hacked the Tesla. And he presented about how he'd actually managed to get inside the Tesla. And the good news was how difficult it had been to do it. Having done it, about all he could manage to do was change the station on the radio. Nothing more critical than that. And even the loopholes he did find, within 48 hours, Tesla had upgraded the patch. And because everything is connected, their security architecture closed those vulnerabilities very efficiently. And they did it in a very open way. And they had given full permission for him to talk and share these learning points with the wider community. Sunlight is the best disinfectant. And they were very open. The less good was a guy from a security consultancy who had successfully managed to hack a whole range of connected devices, from a fridge to an oven to a talking internet-connected doll to an industrial pump to an electricity meter, a whole range of applications, most of which shipped with a default password, many of them a 4-digit numeric password that even if they had changed it, he could brute force and break within a few minutes. And the consequences of that were quite scary. You could turn on an oven on full power until it burnt your house down. He could use the interconnected fridge to monitor your Wi-Fi traffic because you'd entered your password. And so from that, you had full access to your home network and could read all manner of things from that. Huge vulnerabilities. And he was saying these things are not just going into a house. That interconnected fridge could be installed in a company inside the firewall with open access Wi-Fi that he could reach from the car park. And of course, IT guys might think about laptops, but from his experience driving around doing this, most of them are not disabling the Wi-Fi on the internet connected fridge.
Interesting.
So it was very sobering, very, very scary.
So let's talk about security. You released a white paper. You being UltraSOC released a white paper. Talk about the white paper in the context of the options that people should be looking at to secure their IoT networks. I'm going to pop up your slides so you can talk about it. Here we go.
Okay, so one of the things that what UltraSOC does, we're a semiconductor IP company. We design technology that then gets designed into chips. And our technology is all about identifying problems. Those problems could be bugs, they could be hardware failures. But what we've started to do is working with some of our customers, the problem we're identifying is vulnerabilities. So we get designed in as a security architecture that is looking for vulnerabilities, checking if the system has been hacked. And we call it bare metal security because, as you can see in this diagram, we're operating in hardware underneath the operating system.
But at the chip level, when you say hardware at the chip level, and that's a module on a chip?
Yes, it's logic designed into a chip. Because it's underneath the OS, it's invisible. So it's very difficult for a hacker to see that we're there or to disable, subvert, or counteract what we're doing. So we make a very good security system. The analogy I often give is, we complement other security systems. You might have Trust Zone or OmniSecure or some of these other security architectures, and they would be preventing an attack. So they would be the bolts on a door, they would be a lock, bars on your window. But it's possible that someone can get through that they might have the key to that lock, in which case they come inside. And rather than a door lock, we're the burglar alarm. So if someone does get through the door, they come inside, they'll trigger the alarm, and we will be alerted. And that's our functionality. So it's hardware, it's invisible, it's non-intrusive, but it's very, very good at seeing what's going on and then raising an alarm.
So how difficult is it to create the technology to send that alert out? That seems pretty straightforward, but it's like a motion detector in our office here, the ADT has, so that it just simply sends an alert out. What makes that a complicated challenge for a silicon company?
Simply because if you're in a real world context, the ADT alarm, the infrared detector, the door detector, they're looking at essentially something very simple. It's one bit. Is somebody in here or are they not? And there's an access control or a pin. When you've got a chip with dozens of processors, multi-core, many-core architecture, dozens of processors, hundreds of IP blocks, hundreds of millions of transistors, many things going on at the same time, it's much more difficult to know, are those legitimate? Are those authorized? And that's where our IP comes in. We've got some very sophisticated modeling and monitoring things that will allow you to say, this transaction is legitimate, you can have that one, this transaction here, that's not, and stop. Trigger the alarm. When I say trigger the alarm, in a connected environment, that might literally be, as in this diagram, over a private secure channel, send a packet back to the base, which is just like your ADT monitoring, privately, secretly send an alarm. Or it could be in an embedded context, in a Internet of Things context, where that secure channel may not be connected all the time, may not be reliable. We can send a message, but we could also do something within the chip itself. So, for example, we could trigger an alert in the system. We could do a reset. We could drop back to some minimal safe mode, so that if it's in a car, then you might say, hang on, something's wrong here. I don't like this. There's a problem. And I don't really care if that's a bug or a failure or a hack. Any of those things, just flash a light on the dashboard and go back to safe mode. And you would be sure that the problem is not going to endanger anyone's life. And in the ultimate case, we've got one customer, very, very security conscious, very, very safety conscious application. If they think it's been hacked, bam, brick the system, disable it, turn on the red LED, but we don't want any risks whatsoever. So we would act in that case as we would disable the system. And we would do that in a trusted, hardware-based way. And because we're below the OS, almost impossible for a hacker to detect that we're there, and almost impossible for a hacker to stop us or interfere with that operation. So very, very safe, very, very trusted. Now, whether you need that, that's a fairly extreme context. Much more often it would be do a reset, send a message back to base would be the more appropriate response. But all of those things are under the chip designer or the system architect. They can control what we do.
What are some other options for securing an IoT network? I really want to compare and contrast this bare metal solution with potentially other options in the market.
I think when you say compare and contrast, I think one of the things with security is you need a multi-layered approach. And you need to start from the assumption that things are vulnerable, that any one layer will have a hole in it. And so what you're trying to do is cascade these different layers so the cost goes up combinatorially. If you have a 10% chance of getting through one layer, put two of them, that's a 1% chance. Put three of them, 0.1 chance, and so on, in order that you make it very, very expensive for an attacker. You can never make it impossible. One of the things I've heard a lot over the last 2 weeks is it will never be impossible, but you can make it disproportionately expensive, so they won't do it. So the way we contrast, the way we work, is you can have software-based solutions, and you would want those. So passwords, secure OS, changing your password, things like that, running at a software layer. Then below that, you have one kind of hardware-based solution, which is the secure access control methods. Things like Trust Zone, OmniSecure, a TPM, a trusted environment, that are making it difficult, making it so that only certain elements can access different devices. So, for example, there's a company called Trustonic I was talking to the other day. and they make it possible to have trusted apps. You can download an app from an app store, software, and their technology running inside the OS, parallel to the OS, will download the security elements in through a different connection. So you've added another layer of protection. And finally, we would be below even that. We would be built into the chip in gates in hardware, monitoring these different things. So we could say, you're looking at the security coprocessor. Are you allowed to do so? Oh, yes. You're the trustonic environment. We know who you are. You're an authorized user. You can access this block, and you're supposed to be looking at the keys. But someone else, a different process, no. You're never supposed to access the key store. Wah, wah, wah. Sound an alarm. Because we understand the difference between those things at a fundamental silicon level. Very complementary, and you need that. You need these different layers, different methods, because they will each have different vulnerabilities, a different threat vector that you wish to protect against.
Now, will those, including your solution, will those solutions be able to change policy over time? So that these can be, once the sensors shipped out, you don't have to do a forklift upgrade of all your sensors. It's simply a over-the-air upgrade of policy or change in policy.
And that's one of the beautiful things about why Internet of Things and why this connected world is so important, isn't it? You know, that we've had embedded devices, we've had microprocessors and microcontrollers for decades, but the issue has been they're not connected. So how can you upgrade them? Now they're connected. Now you can upgrade them. The bad news is that's a threat vector. The good news is it's also a protection mechanism. So you can upgrade virus signatures, you can upgrade policies. And yes, bare metal security has a role there as well, in that we can be upgraded over the air, which you need because you'll need to understand these new policies. And we need to know who is authorized, who is legitimate, and that needs to update. But also, we can be used, there's a double lock. So we can be used to authorize an over-the-air upgrade, and then we get upgraded, and in parallel, something else can check that we're legitimate.
Got it.
We've got this belt and braces. We check them, they check us. Because in security, again, one of the things that is important is how do you trust your security system? Qui custodes custodiet, who guards the guardian, is a worry. And having that double lock, I check you, you check me, only if we both agree independently can things go ahead. That's a kind of approach that adds value.
So let's wrap up. I want to understand UltraSOC's strategy. You're a silicon research company, if you will, solving very complex silicon challenges, and then I assume licensing that technology to your customers. Tell me a little bit more about your business strategy and your go-to-market strategy.
So UltraSOC, as you say, we're a semiconductor IP company. We develop complicated, sophisticated blocks that would then be integrated into someone else's SoC. There's a very standard business model, very similar to ARM, Imagination, Elliptic, Tensilica as was, Arc as was, now both owned by Cadence and Synopsys. There's an upfront license fee and an ongoing royalty. And the silicon world is very much moving in this direction, that there are more and more blocks that get standardized, and then a chip designer will integrate those. Much like other forms of software, you would no more write your own compiler than you would design your own processor. In both cases, there are products out there. You will use whether it be GCC or Microsoft or whoever, Green Hills, you will license from ARM or Imagination. We're in that same role. We believe that performance monitoring, debugging, and security monitoring are standard elements. Every chip should be integrating these. Every SoC should have these in them, but it's not worth your while developing your own. You should instead license them, license best in breed, integrate it.
Got it.
Cost you some dollars, that'll pay off in time to market and having a better product.
Well, Rupert, thanks for your time today. I look forward to staying in touch and again, frequently engaging you on these important topics of IoT, specifically security. And maybe we'll see you at Mobile World Congress in February.
Very much look forward to it. Thanks
for your time. Take care.
Bye.
IoT Innovation is a production of RCR TV. To find out more about IoT innovation and all things wireless, visit rcrwireless.com.